Hi, in this lecture I am going to walk you through the various hardware components that you need in order to complete again the experiments in this course. As you'll see, we need just a couple of classes of hardware, an oscilloscope of course, and something to generate an input test signal to work with and experiment with in the oscilloscope. Let's dive right in and have a look at the details. So as I said, we are going to need two classes of hardware. First, the test instrument that this course is all about, an oscilloscope of some kind to capture and measure a signal. And then we'll need something to generate that test signal that we'll be working with in the oscilloscope. And we've got a few options in that regards. First of all, a closer look at the kinds of oscilloscope that I would recommend. The top in my list are the Benchtop oscilloscopes. This is the oscilloscope that I use and that I have on my bench, and most of the experiments in this course I demonstrate using this oscilloscope. What I like about Benchtop oscilloscopes is that they are dedicated instruments to doing just one thing and doing it quite well. The Benchtop oscilloscope is designed for the purpose, its user interface, its display, its electronics internally, and the way that it works is optimized for this particular purpose, and it doesn't have to compete with anything else. So if your budget allows it, perhaps you already have one, but if your budget allows it, I would recommend that you invest in a good quality and affordable benchtop oscilloscope. So I said the problem with these instruments is that they can be expensive. So your second option would be a PC or USB oscilloscope. So these devices cost a fraction of what a benchtop oscilloscope does. And they can be quite good, actually. They can be just as good in almost every respect. The issue there, in my experience, is that this is not a dedicated instrument. And on the software side, you can see the software here in the background behind the actual hardware device that makes up this PC oscilloscope, is that it has to compete with resources on your computer, with everything else that is running on your computer. And that can cause a bit of headaches, and this competition sometimes can cause issues with your testing of signals and measurements, especially things that happen very, very quickly. Again, the main advantage of a PC and USB oscilloscope is the low cost. And I found that personally, the trade-off between a budget instrument and good performance can be very good these days with PC USB oscilloscopes. I'll be using this oscilloscope in most of the experiments in this course to show you how it works and how it compares to the full benchtop oscilloscope. So to wrap this one up, if budget is an issue, I do recommend that you look for a PC USB oscilloscope that you can afford, because this is going to be a very good investment for you to learn how to use a oscilloscope, and it will make the transition to a full-sized benchtop oscilloscope much easier than without it. So here's the second class of hardware that you need in order to complete this course, and it's something to generate signals. So on the left side here, I've got just a breadboard with a few passive components on it, just a capacitor and a resistor. And that is one option. I'll be using this option to show you some of the very basic features of an oscilloscope, such as triggering, for example, and it's really easy to assemble. You'll have a test signal generator in no time. In the middle and on the right side, I've got two microcontrollers. There's the ESP32 and the Arduino Uno, and I'll be using those two microcontrollers to generate some more sophisticated and more configurable test signals. In the middle, the ESP32, for example, with the sketch that goes with that, will be able to produce a variety of test signals. And with a capacitor on the tiny breadboard, you'll be able to configure the frequency of those signals that come out of it. And on the right side, we've got an Arduino Uno connected to a variety of sensors And we'll be able to use the oscilloscope to see what the signal that is coming out of those sensors look like, and we'll be able to take measurements. Now, apart from those types of signal generators, again, this is not really necessary for you to do this course, but it is a useful option, is to have a dedicated signal or function waveform generator like the one that you see in this slide on the left side turned on. This is an instrument dedicated to creating pretty much any kind of waveform and test signal that you can imagine, and then we can feed that into the oscilloscope and make measurements or observe those signals. And you can see that right now I'm creating a stare down signal that the oscilloscope is very happy to display. Again, this is not necessary, but I will be using the signal generator to generate a few signals in specific parts of the course, just to demonstrate specific aspects of the oscilloscope's operation.